Class, thank you for watching. This video is on the assignment absolute value inequalities. And again, as usual, my disclaimer is that you have completed the assignment. All you're doing is just checking again your work. So let's begin with problem number one. Problem number one, we want to get the absolute value of 2x minus 4, and we want that to be less than or equal to 14, okay? Since the absolute value is isolated, this inequality means that we have the compound inequality and. So we're going to create this. We're going to create 2x minus 4, have it be less than or equal to 14, and we're going to have 2x minus 4 be greater than or equal to negative 14. So we're going to solve the inequality doing, again, inverse operation. So we're going to add 4 to both sides. That gives us 18. We divide by 2, and x is less than or equal to 9. We do the same thing over here. We're going to add 4 to both sides, but now since we have a negative 14, we end up with negative 10. We divide by 2, and x is going to be greater than or equal to negative 5. So our solution would be the number line that goes from negative 5 to 9 with closed dots above both of them and going towards each other. As an interval, it looks like this. So this right here would be your solution for problem number one. So for problem number two, this is the absolute value of 10x plus 7 is less than 37. Again, because the absolute value is isolated, that means that this inequality, again, is another example of an AND inequality, a compound inequality. So we start by getting 10x plus 7, have that be less than 37, and we get 10x plus 7 and have it be greater than, not equal to, but just greater than negative 37. Let me fix that. So then we solve each inequality. So in the first one, we're going to subtract 7 and we get 30. So 10x is going to be less than 30. We're going to divide by 10 and x is going to be less than 3. Here we'll subtract again 7 from both sides, but this time we end up with negative 44. We divide by 10 and x would be greater than, in a decimal, that would be negative 4.4. As a fraction, I'm going to leave it as a fraction, as negative 22 over 5, which again is equal to negative 4.4 as a decimal. So my number line will look like this. The negative value is obviously first, and then the positive value is second because that's bigger. And because it's an AND inequality, then my answers again should be all the numbers in between those two endpoints. And yes, it does in fact match up. They have to be less than 3, so 3, that would be to the right. And because it has to be greater than the negative value, that's all the numbers to the right, and less than would mean to the left. So this again would be the graph of our solution, and as an interval, our interval will go from negative 22 over 5 to positive 3. And again, brackets on both of them, since the circles have to be closed. So there's your solution. Now for number 3, we have negative x minus 5 is going to be greater than or equal to 2. Again, since the absolute value is isolated, that implies then that this inequality is an OR, compound inequality. So we're going to create two cases. We start by getting negative x minus 5, have that be greater than or equal to 2, and or negative x minus 5 is going to be less than or equal to negative 2. So to solve these inequalities, we're going to start by adding 5 to both sides, and negative 1x will be greater than or equal to 7. We divide by negative 1, and x is going to be less than or equal to negative 7. Remember, we divide by negative, so the inequality, again, we're dividing by a negative, so this inequality is going to flip, as you see right here. Now for the next one, we add 5 to both sides, and again, because it's a negative this time, we're not going to get negative 7. We end up with positive 3. we divide by -1, and x is going to now be greater than or equal to -3. Again, notice that because we're dividing by a negative, this inequality, oops, there, flipped. It now changes the opposite direction. And that's going to match perfectly again because we have an or compound inequality. So my solution should be -7 first, -3 seconds, because the smaller number is -7. Close dots above each endpoint, and they should be pointing away. And they are. They are, in fact, going to be pointing away. Less than -7 and greater than -3. So this is your inequality. Now as an interval with brackets, that should be a bracket. We will go from -infinity to -7 and then jump to -3 and go all the way to +infinity. So this right here would be your solution. All right, moving on to number 4. The absolute value of 7n plus 4 is less than 39. So this again is another example of another AND inequality. So we get with 7n plus 4, have that be less than 39, and 7n plus 4 is going to be greater than -39. So we start by subtracting 4 to both sides on this, on the one on the left, and 7n is going to be less than 35. You divide by 7, and the value of n is going to equal to 5. Now here we do the same thing. We subtract 4, and 7n is going to be greater than -43, however, okay? Not -35, but -43. We divide by 7, and the value of n is going to be greater than, and I'm going to leave this as a fraction, not as a decimal, okay? So we end up with the fraction -43 over 7, which is equivalent to the decimal value of like 6.1, which is around 6.1, okay? But I'm going to leave the decimal value. So on our number line, remember negatives are always smaller than positives, so even if you didn't know what the actual value or estimated value was, I know that -43 over 7 would have to be smaller than 5, since 5 is positive. Now, since this is an AND inequality, my endpoints should be pointing towards each other. My endpoints have to just be open because it's not equal to, and towards each other. And so as an interval, I get -43 over 7 and 5 using parentheses, okay? So those are going to be, that's going to be your solution. This right here is your solution. Okay, number 5. So we have 7 minus 5p is going to be greater than or equal to 43. Sorry, there we go. So this one right here, this is an OR compound inequality. So 7 minus 5p would be greater than or equal to 43, or 7 minus 5p will be less than or equal to -43. So here we would start by subtracting the 7, that's the constant. So this is the one we get rid of. So we subtract 7 from both sides, and 43 minus 7 is 34. It's 34. It is positive 34. We're going to divide by -5, and the value of p would now be less than or equal to, is it 36? I made a mistake, sorry, there. That's supposed to be 36. Okay, 36. 43 minus 7 is 36, not 34. Sorry about that. All right, so we now divide by -5, and the value of p, the value of p is going to be less than or equal to, and again, I'm going to leave it as a decimal, as a fraction, I'm sorry, not as a decimal, so -36 over 5. Okay, so we end up with that endpoint there. Now to find the other endpoint, we'll solve the inequality by subtracting 7 to both sides, and -5p will be less than or equal to -50. We divide by -5, and the value of p would be greater than or equal to positive 10. And because this is an OR inequality, when I plot my endpoints, again, the negative would have to go first and the positive would have to go second. Which is, again, this value is around 7.2, if it's not exactly 7.2. All right, this value, you could estimate that to, well, actually, in decimal notation, that would be negative 7.2, if you want to write it as a decimal. But regardless, that number is going to be less because it's negative than 10. And again, because there's an OR inequality, then the endpoints should have arrows pointing away from each other. So it will be all the numbers to the left of the negative value and the right of positive 10. So as an interval, we say that we go from negative infinity to negative 36 over 5, and then jump from 10 and go all the way to positive infinity. So this is your solution. Now for number 6, the absolute value inequality is 4 minus 9x is less than 49. Again, because it's a less than, this is your AND inequality. Again, make sure that you know the difference between the AND and the OR's compound inequality. So we're going to create a AND compound inequality here. So we're going to start by getting 4 minus 9x is less than 59. And 4 minus 9x would be greater than negative 59. So to solve this inequality, we start by subtracting 4 from both sides. And we get negative 9x is less than 55. We divide by negative 9. And again, instead of writing the decimal value of this, I'm just going to write this as negative 55 over 9, okay? The decimal equivalency of 55 divided by 9, that's equal to around 6.1, well, negative 6.1. But again, I'm going to use the fraction notation of it. So now for the next inequality, we'll do the same thing by subtracting 4 to both sides, and negative 9x would be less than negative 63. But hold on, let me go back. I forgot to do something over here. Since I was dividing over here, since I'm dividing by negative 9, that means the inequality has to switch direction. Instead of being less than, it's going to have to be greater than. So it has to be greater than that negative 6.1. And now let me go back to the other one, all right? So now in this one, we left off after subtracting 4, we're going to divide by negative 9. And x, again, because I am dividing, and that's what I realized it, because I'm dividing by a negative 9, that inequality is going to flip. So instead of it being greater than, it is now going to be less than. So less than 7. So on my number line, the negative value goes first, the positive value will go afterwards. That's from least to greatest. Open dots above both of them. And because it's an AND inequality, they should be going towards each other, okay? And if you pay attention to what it says, you're going to the right of 7, and over here you're going to the left of negative 55 over 9. So this is your graph. And as an interval, you would use parentheses instead of the brackets. And it would be all the numbers in between. So from negative 55 over 9 to positive 7. And that's your solution. Okay, let's go to the back now. On the back, here, because we have operations now on the outside, number 7, we have to isolate the absolute value before we can create the two cases. So we have to begin by first getting rid of the operations on the outside. So we would have to start at number 7 by adding 2 to both sides. and the absolute value, I mean, this cancels out, and 8 times the absolute value of n would be greater than or equal to 16. We divide by 8, and the absolute value of n would be greater than or equal to 2. So now that we've isolated the absolute value, we can now create the two cases and go to step number 2. So the two cases, again, we keep the first thing the same. So we simply just write n would be greater than or equal to 2. Now, because of the inequality that we have right now we can check the inequality. Because of this one, this is an example of an or compound inequality. So either n is going to be greater than or equal to 2, or the value of n will be less than or equal to negative 2. Remember that we switch this and that to create the second case. From this, we switch it to that, and from positive, we switch it to negative. So our solution is going to look like this. Negative 2 and positive 2 are on the number line. Close dots above both of them, and the arrow should be pointing away from each one, which they are. Right here, I should have an arrow pointing to the right of positive 2, and according to this, I have an arrow pointing to the left of negative 2. So as an interval, we're going from negative infinity, there we go, negative infinity to negative 2, using brackets, and using brackets with a 2 all the way to positive infinity. So this is your solution. All right, number 7. All right, so for number 8, similar thing, just with different numbers. So even though this is pointing again is less than, don't assume that this is going to stay as a less than. Just simply, again, you have to isolate the absolute value first. So we have to subtract 2 from both sides first. This would be 24. We divide by 3, and the absolute value of b would have to be less than or equal to 8. Now that the absolute value is isolated, now we can relate and determine what kind of compound inequality this creates. So we start with b is less than or equal to 8, and because of the less than, this is going to create an and compound inequality. So b would be less than or equal to 8, and b is going to be greater than or equal to negative 8. So your solution will look like this. From negative 8 to positive 8, the solutions would be in between. So as our interval, we would have to use brackets that go from negative 8 to positive 8. Now for number 9, the same thing, but this time it's written backwards. But again, we start by getting rid of the constant. So we're going to subtract 7 from both sides. This would be 25. We divide by 5. And the absolute value of p would be greater than positive 5. So now that we have the absolute value, again, isolated, we can now focus on what type of inequality this is, so we know what kind of compound inequality we're going to have. This one's going to create an or compound inequality. So p will be greater than 5, or p will be less than negative 5. So remember, we keep everything the same, as you see right there. We just drop the absolute value, and then we switch, which again, what we did, we switched those two. So here, my number line will go from negative 5 to positive 5. Open circles on both of them. Let me erase that. Open circles on both the endpoints, and pointing away, because again, it's supposed to be an or compound inequality. So let me just write the interval notation. Number 10. So 9 absolute value of k plus 5 is greater than or equal to 68. So we subtract 5 from both sides, and 9 times the absolute value of k would be greater than or equal to, again, 63. We divide by 9, and the absolute value of k is greater than or equal to 7. Now again that I finally have the absolute value isolated, now I can focus on the inequality to determine what kind of compound inequality I create. So this one again is going to create a or compound inequality. So k would be greater than or equal to 7, or k would be less than or equal to negative 7. So again, that means that the solutions would be moving away from the two endpoints, not towards each other, but away from the endpoints. And we should have a closed circles, closed dots above these because again, they're equal to. They have the equal sign. So our interval will go from negative infinity to negative 7, use a bracket there, and it will go from positive 7 to positive infinity, and use parentheses at the end. So this would be, let me use red. This right here would be your solution. That right there is your solution. All right, that was number 10. So that moves us to number 11. So for number 11, we would add 5 to both sides. So notice it's all pretty much the exact same thing. Okay, so we end up with 8. We divide by 4. It's going to be less than 2. Now again that we have the absolute value inequality isolated, we can now look at the inequality and determine what kind of compound inequality we're going to create. This is going to create an and compound inequality. So either x would be less than or equal to 2, and x is going to be greater than or equal to negative 2. And it works out. You just stepped out. So we're going to create a closed dots above these, and the solutions are going to be in between. All right, so as you clearly see, from negative 2 we're going to draw an arrow going to the left, on positive 2 we're going to draw an arrow going to the right, and again, so they're going to connect. Now even though the 2 was first, remember on your number line you're supposed to write these in order from least to greatest, so negative 2 is smaller. So our interval would be negative 2 to positive 2, again using brackets and not parentheses. And then finally, for the last one, number 12. For number 12, we have negative 10 plus 8. Absolute value of v is less than 46. So we would add 10 to both sides, and 8v, the absolute value of v times 8 would be less than 56. We divide by 8, and the absolute value of v would be less than 7. Okay, that's 7. So this inequality, again, because it's less than, that is going to create an and compound inequality. So v is less than 7, and v is greater than negative 7. Remember to switch those, so we get to switch and switch those two. So we end up with our solution is going to look like this. So negative 7, positive 7, again, it's an and, so the two dots should connect. And they do. V is greater than negative 7 means we're going to draw an arrow going to the right, again, to the right of negative 7. And here we're going to draw an arrow going to the left of positive 7. So as an interval, it's like the previous answer, okay? But the only difference is that we use parentheses instead of the brackets. So this right here would be the solution. All right. Okay, I hope again this was helpful, and I hope you got the correct answers. Again, the disclaimer as usual is that you have to have completed this before you actually check the solutions to this. Now, again, thank you for watching. Do not forget one more thing. Do not forget that we have tutorials every Thursday, and have a good day. Bye.